Correct. Thanks, Kevin. Just let you know, you will be in a listen-only mode for the first portion of this of the demo. At the end of this, we'll open up the lines for questions, but for the time being, you'll be on mute. So if there's any questions, you can. Yep. Okay. Well, hopefully you're able to redial in and get a clear signal. As I mentioned, you will be in a listen-only mode for the first portion of this demo. At the end of that, we'll open the lines up and you'll be able to ask questions. At this time, I will be muting you all. So very good. Thank you everyone for joining me this morning. I want to talk a little bit about, as Kevin had talked about, some of the benefits of using 4D modeling during construction planning. Some of the topics we'll be looking at today are the improved reliability and scheduling efficiency, being able to visualize time constraints as well as looking at opportunities for improvement within the schedule. We'll also look at ways that we can optimize use of our critical resources. If you have a lot of labor on site, that's one of your more expensive resources on any job, and being able to visually review and evaluate the whole construction plan and optimize resources helps out with the overall planning of your construction project. And finally, we'll look at how using 4D as a tool for improved communication, being able to identify spatial conflicts and understand project scope and sequencing more effectively. I'm going to go ahead and open up Navisworks now. And give this a second here to refresh in your screen. I want to just give a quick overview. For those of you who've been on the calls in the past, we've covered several of the other different areas within inside of Navisworks, specifically clash detection, the overall use, and even looking at some of the alternative file formats like laser scans. Today's demo will focus more on the 4D aspect, and when I say 4D, what I'm referring to is taking a 3D model and adding the extra dimension of time. And it gives us the concept that we can now show the model being sequenced as it would be if we were to go out and build it based off of a current project schedule. So for those of you who have used Navisworks, this is probably relatively new, but just to give you a quick overview, Navisworks is a file aggregator as well as a clash detection tool that allows us to bring in over 40 different file formats from different design applications, append them all together into a composite model. This model then can be utilized for as we talked about clash detection. We can now link out to external databases, but we can also navigate through this and use it as a tool to virtually understand the whole process before it goes out to the field to be constructed. Inside of Navisworks, this is a building which is made up of three primary trades. We have the architectural skin on the model. We also have a structural framing underneath, and there's some MEP work within inside of that. And what I've done is I want to go ahead and plan out this as I typically would if I were to go out and build this. Now in the past, we typically are working with Gantt charts, as you heard Kevin say. And while these are effective in communicating a baseline showing us where the project starts and where it ends and gives us kind of an overall view of all the different elements in there, it's sometimes difficult to understand exactly how these are impacted by other elements on the site, especially when you start getting into larger projects. Being able to understand the events and how they correlate to one another can become sometimes challenging. So what Navisworks does is it takes this information that's contained in the schedule. Schedules are very effective at saying, who does what and when at what time. We take that information and we can link that over to the parts of our 3D model. And by doing that, we're basically taking the information of the schedule and creating a visual interface to that. So going back into Navisworks, on this particular schedule, or on this particular project, I'm just navigating around on this. To show us off very effectively, within the Timeliner feature, if I open up Timeliner at the bottom of the screen here, this allows me to link over to any number of project scheduling databases, whether that's Primavera, P3, P4, all the way up to P6, or for those of you who are still using Microsoft Project, or MPX derivatives if you're using some other applications as well. Navisworks can pull all this information in. We'll bring in not only the start and end date, but as well as the activity name and some user-defined areas. And where this becomes very useful is we have a 3D model on our screen that I'm able to click on and manipulate and move around and really get an understanding of what the finished product looks like. And then we have our Gantt chart, which shows us the activities that would be utilized to make this project happen. With Navisworks, I can now take those two concepts, the project schedule and our 3D model, and append them together. And this is where we come up with what's called a 4D model. So inside of the Timeliner feature, I've linked over the schedule. And what that's done is it's brought over my task name, but also the start and end date for those particular tasks. Now, part of the linking process is we need to establish what these items are. And if you were on some of the earlier calls, we talked about using selection sets. A selection set is a grouping of items in the model, and I can either select these by clicking on elements. I can scan through the model and enter a certain filter it out by basing on a criteria like object name, discipline, material, and so forth, and save those as a grouping of elements. Once I've done that, I can now link those directly over to the specific tasks on our schedule. So what we're seeing here down below, these are the tasks that were imported from our schedule, and I can simply right-click on one of these and say attach that selection set, which will then reference it to those group of items within our model. Now, we can do this manually just by right-clicking and selecting the appropriate element. However, if I'm using a common naming convention, so in this case, my selection sets that I've created up here on the left, upper left, you can see have roughly the same the same naming convention as the schedule. And I did this intentionally. Within Navisworks, there's rules that we can create that allow us to link some of these items automatically. So therefore, it takes off some of the effort of having to go back and manually link object elements on our model to the appropriate schedule task. And you can see I can create a simple rule here. It says map timeline task from column name to selection set with the same name matching case. Now once I've done that, the last thing I need to define is what type of activity am I creating here. And the reason I established this is when we go through the simulation, we want to be able to show, is this item being constructed, is it an item that's being demolished, or is it an item that's a temporary item? Things like logistic equipment. For example, your crane could be material laydown areas. It could be the site fence, the perimeter fence around your project. Any of these different items, we can now define them as a specific task. So when we show the simulation, we can link a color to them, so it's easier to identify what the particular element is and what its function is. So in this case, I've already linked over the schedule. I've mapped it over to the items on screen, and then you can see for task type, it's giving me an option here. Is it a construction type element, a demolition, or a temporary? Now these are the three standard ones that come defined within Navisworks. I can always go back and create my own color scheme. So right now, if I wanted to use just these three, I could just simply right out of the box ready to go. But maybe I have two types of construction. Maybe I have an abatement that I want to be able to show as a different color, or I want to be able to map out different trades. This is where we can introduce different task types in here and have them referenced as a different color. When we run our simulation, those particular items that match up to those tasks will appear in that different color. This is allowing us to quickly visually identify what that particular task is. So enough of the talk. Let's have some fun here. So I've gone through the process. I've linked over my schedule. I've mapped those over to the elements on my model, and now I've defined what type of task these are. So in the Simulate tab, right now we have a black screen. We have nothing in place. When I click on the play button, you'll start to see elements come on screen, and I'm just going to pause this here just to give it a second to catch up on your end. The light green is referencing construction items, or items that are in process at this time. At the conclusion of that time frame on their schedule, they will show up as they do in the model that we were looking at earlier. So the nice thing about Navisworks is that while this is going on, now I can move around the model in real time. I can come into an area inside of this. Let me just scan over here. And now I can introduce a scale avatar. And where this becomes useful is now it quickly allows us to start to inspect the job virtually and start to look over areas where we need to. Let me just go through the wall here. This gives us the opportunity to start looking for areas where maybe we need to look into account for more safety. For example, if we have some openings in the ground, we need to be able to make sure those are properly cordoned off. But with this now, I can virtually walk through the site and I can see the proper sequence of this. So it gives me a different perspective. It takes me into the view of the superintendent. Now I'm able to walk around virtually while this project is going together. And I'll go ahead and start the sequence again. So it allows me to look for errors, omissions, even logic error in our schedule, and go back and make those changes. But it also gives us the opportunity to look for areas that we can improve on. Once again, let me just pause this here. Maybe we have too much work going on in one portion of the site. If we spread that out, we can maximize that and reduce trade stacking issues. It gives us the opportunity to identify these, go back and make those changes in the planning process, that is. We can also look at it from an equipment standpoint. Maybe we have a small excavator or a crane on site for this particular job. Looking at it from a different view, we might realize that we can maximize our productivity if we have two cranes on site and speed up the full overall construction process. And we can start doing these what-if scenarios just by dropping in different items. So at this point, we're looking specifically just at the model. We're not looking at any additional elements within there. What I want to talk a little bit about next is how we can now take this basic model, and I'm going to back out of it here just a minute. And looking at it from a 4D standpoint, we can see how it all fits together. But a lot of the planning process that goes in is still done in a 2D 2D atmosphere environment. We're taking site plans and we're drawing elements, showing where the site trailers will go, showing where the fence is, and items along the lines of that. While that's useful for understanding the overall process, we can now take our 3D model and we can now simply drag and drop in different elements that are representative of the equipment. So in this particular case, I'm going to go back to our full-fledged model. We have no logistics in here, or any of the other elements that would typically be involved in producing a project of this size. I've created a library, a construction library, and this has common components. It has your trailers, it might have your material containers, it might even have things such as a tower crane. And what I can do is I can simply link out to this, and I'm going to link in this Grove crane. And I'm using a SketchUp file here. And the point I'm trying to make is it doesn't necessarily have to be intelligent information. You don't have to go out and model this in AutoCAD or Revit or any of the different design applications. You can go out to Google Warehouse and use a SketchUp file and simply pull this in, and it's providing a place marker. It gives us a visual reference of what this crane is going to be, where it's going to be positioned. And then if I use the object manipulation tools here, I can simply click on this crane, and now I'm just going to drag it out. I'm going to bring it out here to the front of our area. And I'm just going to rotate it about 90 degrees. And very easily, I'm able to just drag and drop equipment in our model now. And by doing that, it gives us a completely different view. Now I can start to determine placement. I can look at the swing of this crane and realize, where do I need to place this? If you're working in a tight site, you may not have the luxury of being able to freely move equipment around. So you need to be able to plan that out and figure out, if I position a crane or some other piece of equipment in this particular area, is it going to give me the reach necessary for that? A poorly positioned crane is not only going to cut down on the efficiency, but it also could technically pose a safety issue as well. So very easily, I'm able to drop equipment in. This equipment can also be linked into our schedule. As I mentioned earlier, when we were doing setting up our task type, we can define, are we constructing or demolishing? In this case, this would be a temporary item. So now I can specify that this crane is useful only maybe in the first 2 months of this construction process. And this starts opening up ideas where we can start looking at time-space conflicts, where we have multiple items that occupy the same time and space, but they're separated by time. In this case, this crane would be used only in the first couple of months, and then maybe afterwards it becomes part of a laydown area, and then towards the end of the process it becomes a landscape area. There could be a sidewalk, and maybe there's like a garden or something out front that's part of this building. So if Navisworks, this allows us to now link all these elements in, and when we define them in their schedule, these elements will appear and disappear at the appropriate time. So I've given you a quick overview of looking at the basic process and then bringing in some equipment. I'm going to jump over to another model that has a little more logistics embedded in it already. And this is the same project, but now we've put this in the context of a city, of a very tight urban environment. And on top of that, you can see we've put in some other equipment. We have a tower crane, we have a series of material boxes, we even have the porta potties, and as well as scaffolding that's been configured for this particular project. Through the same process, I've gone out and I've linked out to my project schedule. This is a Primavera schedule, but the nice thing about Navisworks is that we can link in multiple schedules. So if our project schedule doesn't have things like the logistics planning or some of the other items, maybe 2-week, 3-week look-aheads from some of our subcontractors, we can take all this different schedule data, link it all together in the model. So this becomes useful. It keeps your project schedule relatively free, and most owners, most contractors should say, really don't like to put more on the schedule than they need to. Some of it goes back to entitlement issues, but a lot of times the schedules, project schedules that they're sharing with owners are kept relatively simple, for that matter. They may have an internal schedule which has a little more detail to it that's used only within the organization, not necessarily shared with the owner. So in this case, I'm able to link in multiple schedules. So I have the standard project schedule, which is representing the beam work, the MEP, the architectural envelope, but then I also have a separate schedule which is referencing some of the equipment here on site. And in this case, I'm going to run through the simulation of this as well. And you'll see how it's used in a, back all the way out here to the beginning. It's very similar to this, but now when we start adding logistics, it helps us really understand the context of where this project is built. We can now start to identify areas where we need to maybe move things around, improve them, and you'll start to see some of these time-space issues that I was talking about. So I'm just going to run this again, and now you'll see, you start seeing some of the elements come onto screen. And the same thing as this is going on, I can now freely move around this project. So on a project of this scale, let me zoom in here real quick. You know, they're showing the guardrail on the side of the slab. You know, and from a safety standpoint, this is the kind of information that becomes useful. Not only looking at how it's put together, but any other pitfalls that we need to be aware of. And once again, I could walk through the site while this is going on. I'll let this just run out its course here. And then you can see the scaffolding coming and going. And once again, from a planning standpoint, we need to be able to figure out, when is that scaffolding delivered? Is it stored on site? When we take it off, how do we handle at that point? So these are the kind of tools that Navisworks allows us to do. We can simply take the model, and now we can embed this with our schedule information, and we can recreate different scenarios. We can start looking at a planning A versus plan B and determine, you know, can we fast track portions of this building? What would be the downsides to that? And really allows us to analyze these what if scenarios and figure out and optimize the most efficient way of producing this structure. So up to this point, I've showed you how we can animate in some of these different objects. Now there's also the ability to animate objects on screen. And for this, I'm actually going to show you a video because I think this shows it a little easier. I'm going to go out to my desktop here. And I have this video, and this is of a structure. And I apologize if it seems a little choppy on your end, but the finished video, if you can download this, will probably show it a little clearer. We showed the site being excavated, and now we actually have a camera which is panning around this as well. And once again, through the same process, we're able to see how all the elements are appearing, and we can start looking for out-of-sequence activities. If we see an item that's kind of hovering in the air and there's no support structure around there, chances are we need to go back and make changes in within the model, either it's either designed wrong, or else there's some omissions within the schedule that you need to go back and make it aware of. But this particular case, this is a simple fly-through that shows how all the process would come together, make sure that the envelope of the building is closed off before we start doing some of the internal drywall and MEP systems, and it really allows us to start looking at the whole picture. And then it finishes up with the furniture being installed, and that's the final view of that. So these are all important areas that Navisworks allows us to work with. If we're taking our 4D model, we're able to animate not only the camera path, but actual objects within the model, and then we can then save these different vantage points and recreate the simulations of looking at Plan A versus Plan B. And as I mentioned earlier, this is a way to validate the effectiveness of the schedule, but more importantly, to start really understanding the overall sequence. One of the overall goals we're trying to present here at Navisworks is that we want to improve the communication between all project stakeholders. If we can show this sequence and have everyone, all the subs and the disciplines involved on a job, understand their role and how their role impacts the people around that, we can go out and have a much more successful project. So this is some of the earlier stuff that we were showing you, how we're able to analyze that. Up to this point, we've been using just the Timeliner feature, the Timeliner module, which allows us to bring in not only schedule data, but be able to link in animations and different task types with that. One of the other features inside of Navisworks is what's called the Clash Detective module. And this allows us to look for clashes between, not only physical clashes between components, but we can also start looking for soft clashes. So this next part of the demo I want to talk a little bit about is looking at areas where we have two objects that are going to occupy the same space but at different times. And I kind of alluded to that earlier when we talk about time-space conflicts. In this particular model, this could be a mechanical room in a project. We're looking at a couple different things here. First of all, we've brought in some laser scan data. So this is a model that shows an existing condition. This particular building was 100 years old or more than that, and did not have any design documents out there. Rather than sending someone out to try to measure this with a tape measure and sketch it out and then go back and recreate this in CAD, there's not only the added expense of that, but there's also potential safety issues if they're climbing around in a lot of unknown areas. This particular model, we were able to go in and take a laser scanner. We were able to scan, take a quick shoot of the whole downstairs, and now we have a series of points which are geospatially represented, which give the illusion of an object. It's actually millions and millions of little points is what you're seeing on screen. What I've been able to do is I've been able to link in parts of the new model. So this particular vantage point shows us how now we're going to leverage both the clash detective but also the timeliner feature in Navisworks. We're able to link in a project schedule, but now we're also showing that if you look closely over here, we can see that this magenta pipe is going right through the middle of these blue uprights. And I'm going to change gears here. I'm going to show you what this looks like currently if I were to use the clash detection. So I'm going to basically clash these two different elements. And in doing so, it found 3 clashes. Under the results tab, it's showing me that we have a hard clash here. So this would be a showstopper if we were going out in the project, or, well, that wouldn't necessarily be a showstopper. We'd have to reroute the pipe around this probably. And in actuality, what's happening here is that this particular model, let me minimize the clash here. This magenta pipe is an existing condition that is actually going to be demolished, and the cyan steel uprights in the background are going to replace that. So if I run the clash test on this, once again, we've linked in our clash, we've configured this for, is it a construction or a demolition? And once we've done that, I can now run the simulation of this, and we're going to see the items being demolished, and we'll see the new structure being put in its place. So in the timeliner, it shows up just fine. And when we go back into Clash, I'll show you how we can now link timeliner into the clash detection module so that we can avoid some of these false positive tests. So it might have been a little hard to see, but there was some existing pump work that was demolished out of this particular project, and then we had this new structure that was dropped in its place, and we were able to sequence this in and figure out, make sure that this is all going to work together. So if I go back to the clash detection module, and this time, instead of just running and saying, looking for all the hard clashes within the project, I can now say, I want to link over my schedule, my timeliner schedule. And this becomes useful, and now that even though we have these clashes, they're occurring at different times. The item is not, both items are occupying different portions of the time spectrum. So when I run my clash test now, you'll notice that I'm getting 0 clashes on this particular item. So this becomes useful when we're starting to look at our planning process. Now we can start figuring out, we can place certain items on our schedule and know for a fact that they won't clash, they won't run over into maybe the next activity that's going to currently utilize this space. Now, where you're looking at it from equipment as well as building materials, the nice thing about this is with Navisworks, we can bring in other information and have that be representative of trades. So I could bring in a generic volume that might represent the footprint or the outline of the area that, let's say, a plumber would work in. I can also do the same for the electrician. And using the same process of linking over, I can create work packages as a schedule and make sure that the electrician and the plumber aren't going to be working in the same area. And this, in effect, cuts down on trade stacking issues. And you know what happens if you have too many people working in the same area, your productivity will typically plummet quite a bit. So this is a planning process that we can now utilize to not only look for clashes, to figure out how the building's put together, but start managing the trades as well as the equipment that would be typically involved in this. So I want to go back to our conference center and talk a little bit more about this, and then I have another video I want to show you. And we're on a little bit of an abbreviated schedule today, so I will have plenty of time for questions, but wanted to go back to this again and just kind of reference the advantages of 4D. And we're looking at it straight from a view here, but if I back out of this project, and I think this is something that becomes useful when you start looking at the context of the project, and I'm just going to back out here quite a ways. This particular project, to kind of put it in perspective, is positioned in downtown Boston. And so once again, we're able to look at this overall project not only from the macro level, looking at it from just within the perimeter of the site, but now we can look at it beyond that. We can start planning out our logistics, the deliveries, and using a 4D aspect, we can start saying, you know, we have some space over here on the side, we can store equipment here. Once that gets installed, then this becomes the phase 2 of this building, or it becomes the next slab that's going to get poured. We can start to identify these kind of areas and incorporate that in our planning process. So even something that's in a tight area like this, there's still plenty of potential to be able to go back and maximize the use of the site. Obviously, there's other areas around here, like maybe there's like a vacant lot across the street that could be used as staging areas as well. But this becomes very useful for figuring out what kind of equipment can be placed in site, and on top of that, can we reutilize some of the space going back and forth, and you know, having it as a laydown area, then it becomes part of the project and so forth. So 4D is not just about just the straight process of linking in you know, the time and saying, you know, let's show me what this video, create a video that shows how it all goes together. It's really more useful from a planning standpoint. It allows us to pull all this information together and start making very educated decisions about the best way of producing this. And on top of that, by doing that extra planning, you're going to find that your safety becomes very important. You're able to identify a lot of these potential pitfalls ahead of time and mitigate those risks without having to, you know, suffer the effects of having an injury or even, you know, the loss of a life on site. At this time, I want to show you with one last video, and then we'll do a wrap up, and then we'll have some time for question and answers. So this last video I want to show you, and this is one that was utilized for the Bay Bridge, and this is a fairly large-scale project that's ongoing right now in the San Francisco-Oakland area. And with this one, they utilized a variety of different functions that we talked about today. They're using the timeliner, but they've also used the clash, and then you'll see how they've been able to animate portions of this. So this becomes a useful tool for understanding the overall scope of this, but more importantly, it can also be leveraged to share with the public so they can get a very good view. Law enforcement, if they're going to be having to understand, maybe there's you know, some enhanced security that's going to be involved with that. I'll just play this right now. And like I said, once again, I apologize if you're unable to see this, but within the once we share this, you'll be able to come back and see this firsthand. So these are some images, just some still images showing some of the initial process, some of the equipment that's embedded in these towers. The last portion of this video, starting now, is showing us the sequence of this. And you can see the objects appearing on screen. You can see up in the upper left, they have their own color code identifying what the different tasks are. And then to the right, it's giving us a listing of all the components that are currently going on, as well as the percent partially complete. And we'll just let this play through. And this is the unabridged version. There's actually a full version which goes on for some time, which shows even more of this. But this is a great view because it shows us it's been rendered to appear as photorealistic. Let me just fast forward up here to a portion of this. I'll just pause it here. They are able to bring in some background images, some imagery to really put it into context of what we're looking at. And you can see they've put in some things, the scaffolding, the cranes, even the laydown areas. They modeled all of that. So this is where they've been able to use 4D and really make sure that they have the proper sequence, that they have the ability to store these items, and that it can go together in this sequence. So this is a great tool to be able to look at not only how a building's put together, but planning out the logistics of the overall site. I want to finish up, talk a little bit about what we saw today. So we looked at maximizing your schedule efficiency, being able to reduce the errors, omissions, and validate the planning process. We looked at that from a couple of different ways, being able to look for errors and omissions or even scheduling logic within the schedule, but also looking at being able to maximize the efficiency in terms of, can we fast track portions of this? By being able to virtually see the construction process, we can look for areas to improve and optimize that efficiency overall. Being able to evaluate the whole construction plan and enable site logistics more effectively. We talked about bringing in something as simple as a crane, and it doesn't necessarily have to be modeled in AutoCAD. It can be something that you can go pull out of Revit or Google Earth. Any of those different applications can be leveraged inside of Navisworks, and it's just something that represents that space that object's going to be occupying. It can be useful for evaluating the plan and determining the best layout for all of your equipment. And finally, looking at a way to improve the communication for all the project stakeholders. I think this is probably one of the key items that, if we walk away today, at least, understand that with Navisworks, we're out to try to have everyone understand the full scope of the project. Not only seeing how items fit together and making sure that collisions and clashes have been dealt with in the design phase, but now we can maximize the efficiency of the overall project by linking out to a schedule and seeing how that whole process fits together. And really, it validates the whole process, the whole construction planning process. Not only can we see the results of the schedule, but now we can start seeing the areas and opportunities where we can maximize non-design elements. So at this point, I'm going to unmute you, and we'll have some time here for questions. Okay, Kevin? Okay. Sure. So when we were looking at that construction process, in this particular case, the architect had created the base model. The contractor, the CM in this case, took in that architectural model, but had these other models that were done by the appropriate subs. And there were more than anything, they were like shop drawings at this point. But part of the process was to submit it in as a 3D model. So we had the mechanical, which was most of the MEP portions of the project, and then we had a structural model, which was done by the structural engineer and supplied as a 3D model as well. And these three models were brought in together. Some of the logistics portions were actually done by the CM. They were able to use this 3D model as a planning process. And typically at that time, when they're going around, depending on the contract language and how these models are shared, sometimes the models aren't given out. The contractor is given a set of 2D drawings, and then they'll actually go back and model this themselves to create that 3D view. Sometimes they're working with more of a design build type application, or even the buzzword we're hearing a lot about now is integrated project delivery, where the architect, the owner, and the contractor all work together as one, and we're seeing some more model sharing effects. But depending on how it's set up, it's a combination of that. The architect will still continue to update the model for changes that are made, and we'll typically republish that. That updated model can be brought right back into Navisworks and be updated in the application. And the same goes for the other applications. And then some of those were actually modeled by the contractor as well for, if they just received maybe a 2D sheet saying, make these following changes. Okay. Yes and no. Depending on the contractor, we have some subcontractors that are very proficient in 3D, and they've been doing this for some time, and then they either dumb down their model and save it as 2D sheets from the old, the way they used to submit in the past. We've worked with a lot of trades though that have been very hesitant about going down this route, and for them, the first step I think is, thinking in 3D, or thinking it's this huge investment. And the process we're trying to establish is that take baby steps. We don't expect you to change your whole process and come out with a perfectly coordinated 3D model. But start thinking in 3D, and it doesn't necessarily have to have a lot of intelligence, because really, we're looking at the geometry. We want to make sure that it's fitting into a certain area. Down the road, when we can start embedding in intelligence into that model, we can then extract that out. And you can look at quantities and other information, and even asset management when you look beyond the life cycle of a whole building. But just starting that initial role of starting to think in 3D and looking at the different applications, Navisworks is fairly file format neutral. I mentioned it brings in over 40 different file formats. So they could be doing this in AutoCAD. They can be doing it in even something as simple as SketchUp. But the point is, it needs to be represented. It needs to be somewhat accurate for the overall process to be effective. But what I found interesting about it is a lot of the people that were very hesitant after they went through one or two of these processes were very excited about continuing down, and said, we'll never go back to 2D, just because they've seen the benefits right away. They've seen the fact that they can now submit their information, they can plan around that, and they're having fewer callbacks, fewer design changes in the field. So for them, it's a cost-saving tool as well. Correct. So yeah, you can link to an external database. That's correct. So an ODBC, SQL, Oracle, Access type databases, you can link out to that, and then property information in those databases can be embedded in the Navisworks model. So it gives you the ability to click on an element. Maybe it's a steel beam, or maybe it's like a construction piece of equipment. And if it's linked, you can link that to a database. So now you can bring up an enormous amount of information which normally wouldn't be modeled into the project. Yes, it's through the interface. Yes, there's a correct. Yeah, there's a module called Data Tools, and it allows you to write the SQL script right there, and you can link out to, as I mentioned, pretty much any of the ODBC type databases. Okay. Absolutely. A lot of the larger contractors that have been utilizing this have been doing some case studies. There was one that I sat in on a couple months ago where it was about a 3-to-1 cost savings, from using 3D and 4D type applications versus non 3D 4D. And they showed specific examples where they figured out the price of an RFI in terms of the man hours to process that, the downtime, and just by going through and eliminating an RFI or two just based off of that, and they're coming back with a substantial cost savings, in some cases up to six figures. And this is money that is just saved just from, it's not adding any additional time. If anything, it's shaving off time. But they're able to quickly validate these design decisions that much quicker and identify them early enough in the design phase so that out in the field, we're not having to wait for, the design team to come back and make a change, or, if there's a conflict, having to reroute and maybe order new materials to, for that that new condition. But there are some studies out there. I can see what I can find out. I can send it off to Kevin, and he can share that with the team, because it is impressive to see some of these metrics in terms of the ROI that a lot of these users are able to realize. Correct. Yeah, I'll see what I can find, and I'll send that off to Kevin, and then he can share that with all the attendees on the call today. Okay. Okay. I appreciate your time. Thank you. Bye now.